Thank you. All right, so like I said, we're going to talk about operations on functions, and some of this is review for us. It's just a new notation. Like we have added, subtracted, multiplied, and divide polynomials before. We've done all of that already. So this is just a new notation signifying what we should do. So if we want to find the sum of two functions, a notation for that is in parentheses f plus g of x. All what that means is we take our two separate functions, f of x and g of x, and we add them together. So we look for like terms and combine our like terms together. If we want to find the difference of two polynomials, or two functions like f minus g of x, we just take our two functions, f of x and g of x, and we subtract them. So we find our like terms and subtract our like terms from one another. Product, f times g of x, we just take our f of x and our g of x and multiply them together. So if we have two binomials, we would be foiling. If we have a binomial with a trinomial, we'd have to think about distributing throughout. And then the quotient is dividing, so f over g of x, we just take f of x over g of x. And we've done all of these types of functions before, so it's just a new notation that we have to look at. Okay. And then for the quotient, if we have f of x over g of x, we would just look to see if they have common factors that could cancel. All right, so we're going to do an example. So I'm going to give you two functions, a function for f of x and a function for g of x. We are going to find the sum, the difference, the product, and the quotient between the two. So if f of x is x squared minus 3x plus 1, and g of x is 4x plus 5. We are going to find the sum, the difference, the product, and the quotient between these two functions. So we're going to add them. Add the like terms together, subtract the like terms, we're going to multiply them together, and then we will also divide them. And then it's just using the new notation for it. So the sum, f plus g of x, we just write the f plus g in parentheses. That's telling us that we are going to add our two functions together. So we want to take a look at these two functions and see what our like terms are and combine our like terms. So if we have x squared minus 3x plus 1, and then we want to add 4x plus 5. So x squared, are there any like terms over with the g of x one? No, so we just leave that x squared. Then we have a negative 3x, we want to add our 4x to it, plus x, and then we have a 1 plus a 5, plus 6. So there's our f plus g of x. Okay. The difference, so f minus g of x. So now I want to subtract my like terms from one another. Some of you may find it useful to write this out with subtraction signs or the opposite signs in front of your g of x. So if I'm looking for f minus g, I might write out x squared minus 3x plus 1, and then minus 4x minus 5, so that I make sure that I have my signs correct. Okay. So we want to make sure we subtract everything. So if I get my like terms together for this, what would I have? X squared, yep, minus 7x minus 4. Those two okay? Yeah. Okay. The product, so f times g of x. Well, f times g of x, we would have to take our x squared minus 3x plus 1 and multiply it by our 4x plus 5. How do I multiply these two types of things together? Yeah, distribute. So start with the 4x and distribute it to all three of those. So 4x times x squared. 4x cubed, yep. 4x times minus 3x. Minus 12x squared. 4x times 1. Plus 4x. Then do the same thing with your 5. So 5 times x squared. 5x squared. 5 times minus 3x. Minus 15x, and 5 times 1. Plus 5. And remember when we did this earlier in the year, we lined up our like terms with one another right away, so we could easily combine them together. So what do I get when I combine these together? 4x cubed, minus 7x squared, minus 11x, plus 5. So f times g of x is 4x cubed, minus 7x squared, minus 11x, plus 5. And then the quotient. So we want to divide them, f over g. Now, when we are dividing these polynomials, the only way how we could simplify it is if we had a common factor that we could cancel. So we would want to take a look and see if we could factor our quadratic. So our quadratic here is x squared minus 3x plus 1. Is that factorable? No. Why do we know it's not factorable right away? Yeah. 1 times 1 would have to be our last values. First values have to be 1 and 1. There's no way that our outside and inside will give us negative 3. So that's not factorable, so we will just put our f of x function in the numerator and our g of x function in the denominator. And there are our four values: the sum, the difference, the product, and the quotient. I'll review. We've done all of those types of things before. Is that okay? Okay. So those four operations we know of and are familiar with. So now there's a new operation we're going to learn today. And it's called a composition of functions. So a composition of functions essentially means that we're going to take one function and compose it into the other one. So we've done things like this before, we just haven't called it a composition of functions. So here we're going to suppose f and g are functions. And the definition of a composition is that the range of g is a subset of the domain of f. Essentially, you are going to take your g function and you're going to plug it in for all of your x values in your f function. And a composition of functions, it's an open circle. That means that you're taking the composition of functions. It's a small open circle in between. This is said as f of g. So you're taking your f function of your g function. And it is also written like this, f of g of x. Once again with the open circle. Instead of putting a little open circle there, you can also write it with parentheses or brackets. So this is saying, once again, f of g of x. So instead of just having an x there, we have a whole nother function. So we are going to find, I'm going to give us these two functions for f and for g, and we're going to find what the composition is, what f of g is, and then we're going to find it in the reverse order as well, what g of f is. Perhaps we got some more space. So what we need to keep in mind is this setup right here, okay? Because if we keep this in mind, that actually is going to allow us to be able to find this composition of functions a little bit easier. So f of g. You're supposed to just give it to me anyway, so. All right. F of g of x. So what we're going to do is we're going to take our f function of g of x. Okay, so I just took that writing and I rewrote it out. Now it's a matter of substituting in what we know. So do we know what g of x is? Yeah, it's right here. Okay, so I want to take my function f of my function g. So what that tells us is that for every time we see our x value here for f, we're going to substitute in our whole entire g function. The way how you guys saw this before is it would have actually been written out this way for you. F of x squared plus x minus 1. And you would have taken this entire function and plugged it in for your x values over here. The difference is I'm not telling you the x squared plus x minus 1. I'm just going to call it a function g. Okay. So here in the f function, I'm going to take, instead of writing x out, I'm going to write out x squared plus x minus 1. So instead of x, it's x squared plus x minus 1, and then we still have a plus 3. And now we just need to simplify that. So we look, common terms that we can get together. The minus 1 plus 3, right? Those are like terms that we can add together. So our f of g, our composition of functions this way, would be x squared plus x plus 2. So we took our g of x function, the x squared plus x minus 1, and we substituted it in for our x value in our f function. Okay, so now we're going to go the other way. So now we're going to do g of f. So g of f of x. Okay, so now we're starting at the function g here. So here's our function g. And instead of these x's, what would I replace each x in this function with? Yeah, this x plus 3 right over here. Okay, so instead of writing x squared, I'm going to replace it with x plus 3 squared. So this will say x plus 3 squared. Plus, instead of x here, it needs to say x plus 3. And then minus 1. And now we simplify this. So x plus 3 squared. Oh, how would we simplify that out? No, we can't cancel them. We're adding them together here. And this first one is an x plus 3 squared. So how do we simplify that? It's not just x squared plus 9, nope. Yeah, x squared plus 6x plus 9. Why does that 6x have to be in there? Yeah, there's two terms here. It's an x plus 3 times an x plus 3. The outside and the inside you need to take into consideration. Now we still have an x plus 3 and a minus 1. And now from here, if you get your like terms together, what do we have for our like terms together here? We start off with an x squared. And when you get your x's together, what do you have? 7x. Now we have 9 plus 3 minus 1 plus 11. So g of f would be x squared plus 7x plus 11. All right, we'll do another one like this, where we find f of g and g of f. The same idea. We're going to find f of g and g of f. We just have two new functions here. This time we have f of x is equal to 3x minus 4, and g of x is equal to x squared minus 1. Okay, so we'll start off by finding what f of g is. So if I want to find what f of g is, what will I replace all my x's with in my f of x function? Yep, I'm going to replace each x in my f function with x squared minus 1. So when we see f of g, it's just like f of g of x, another way to write it. So here, f comes first, so we start with our f function, which is 3. Instead of x, replace it with your x squared minus 1, and then minus 4. How would you simplify this? Yep, distribute the 3, so this would be what? Yep, 3x squared minus 3, and then minus 4. So now simplify. Bless you. And what do we have for our fully simplified answer here? 3x squared minus 7 is our f of g. All right, so let's do the other one. G of f. So G of f. So every x that I see in my g function, what will I replace it with this time? Yep, now I replace my x here with my 3x minus 4, because it is like g of f of x. So instead of x squared there, I would say 3x minus 4 squared. And then we have a minus 1 still in our g. Okay, 3x minus 4 squared. Remember, that's 3x minus 4 times 3x minus 4. So you have to visualize what the outside-inside would be for foiling. What would that be when you multiply it together? 9x squared, yep. Oh, you're missing the outside inside. Yeah, minus 24x. And then plus 16, and then we still have the minus 1. So, get your like terms together, and what will we have for our final answer here? Plus 15, yep. So 9x squared minus 24x plus 15. Are those okay? So it's just a matter of replacing one function for your x's in the other. You just have to keep it straight as to which one. And last but not least, we're going to do the f of g and the g of f with some numbers in there. So I want to evaluate what my f of g and g of f is for these two functions if my x is equal to 2. Now there are a few different ways you can do this. One of the ways is you can go ahead and find out what those functions are with as written with variables. What we did for the previous two. The other way is to just think about it as the composition of functions and how it's written out. So for number 1, if I want to find f of g of x, that is f of g of x written out. And what value for x do I want to find this for? What does it say? What does our value for x want to be? What should it be here? 2. So this is really the same thing as f of g of 2. Well, now if you think about order of operations, you start with your innermost parentheses and you work your way out. So g of 2. So for your first problem here, what would be g of 2? How would we find that out? Plug a 2 in for it. Okay, so g of 2 would be 2 squared plus 2 minus 1. Well, what's that going to be? 5. All right, so instead of g of 2 here, what can I replace g of 2 with? What did we just figure out that was? 5. So we're going to replace it with 5 because that's what it's equal to. So now we really want to find out what f of 5 is. And how do we find out what f of 5 is? Yeah, plug it into your f function. F of x is x plus 3, so if your x is 5, okay, 5 plus 3, what's that? 8. So your f of g of x, for when your x is 2, is equal to 8. Is that okay?
How did you get the g of 2?
G of 2, we went up here to our g of x function and we plugged the 2 in. 2 squared plus 2 minus 1. 2 squared is 4 plus 2 is 6 minus 1 is 5. Okay, for example 2, let's do it the other way around. Let's find g of f of 2. Okay, so we'll first rewrite it to what it actually means. So this means we are finding g of f of 2. So what would we start off by looking for first? F of 2. Okay, so for our second example here, our f function is 3x minus 4. So we want to find f of 2. So we would want to find out what 3 times 2 minus 4 is. Yep, that's 2. So instead of f of 2, what can I replace that with? G of 2. Okay, and then how would I find g of 2? Put the 2 in for the x. So here we have x squared minus 1. So 2 squared minus 1 is 3. So g of f of 2 is 3. And these are the same exact functions that we found earlier. So our g of f of 2 here, if I go back a screen, here's our g of f. If we plug in a 2 for our x values, we would end up getting 3. 2 squared is 4, 36. 24 times 2 is 48. 36 minus 48 is a negative, what did I say this was? 36 minus 48. (36 minus 48) is a negative 12, and then we add 15 and we get 3. That's exactly what we got here. Okay. This method probably would have taken us a little bit longer to find out what g of f was first, and then plug 2 in, where here we could just deal with the numbers because we knew what number we wanted to evaluate it at right away. Okay. Same idea for the first one. We found out that f of g of 2 was 8. So that was this example. So f of g, if we figured out what it was at 2, 2 squared plus 2 plus 2, well, 2 squared is 4, plus 2 is 6, plus 2 is 8. And that is exactly what we ended up getting here for this answer. So it doesn't matter which way you go about it, but dealing with the actual numbers is probably going to be slightly quicker. All right, so we've got a worksheet